Good afternoon, Antioch Bears. The further you go in algebra, inevitably you're going to have to deal with polynomials. We started talking about this in class the last couple of days, and I wanted to prepare a video for you guys to show all the different things you might have to do with polynomials as we continue through Algebra 2. One thing you might be asked to do is to add them. Here's one of those situations. We got a binomial plus another binomial. 2x to the third plus 4x is being added to 3x plus 9. When you're asked to add polynomials, you're looking for like terms. The first term I see is a 2x to the third. As I look around, I see no other x to the thirds in this particular set. So he's just going to come down for the final answer. I'm going to cross him out so I know I used him. The next term I see is a positive 4x. In the other binomial, the one on the right, his like term is a positive 3x. If you add 4x plus 3x, you get a positive 7x. Notice that nothing happens to exponents when you're just adding and subtracting. There's also a number in the second polynomial, the binomial, the positive 9, who has no like term, so he'll come down as part of the answer. You end up with 2x to the third plus 7x plus 9. By the way, I should have mentioned this at the beginning, but you're welcome to pause this video anytime you want if you want to try these by yourself before I work them out. The harder one for a lot of students is when you're asked to subtract polynomials, because they keep forgetting that mathematics is read left to right. So when you're asked to subtract a negative number, for example, it actually means to add. To minus a negative will mean to add. But we're getting ahead of ourselves. The first term is 5y to the second power. Its like term is 7y to the second power. In order to be a like term, it has to be the same variable raised to the same exponent. 5y to the second minus 7y to the second gives me a negative 2y to the second power. Negative 2y is a like term with negative 10y. And where the mistake usually happens is students will see negative 2 and negative 10 and come up with negative 12y in the middle, forgetting about the fact that they've been asked to subtract them. So this literally reads negative 2y minus negative 10y. Minus a negative turns into a positive. So now it's negative 2 plus 10, like this. And that actually makes a positive 8y. Finally, positive 3 is asked to subtract negative 9. 3 minus negative 9. Think about that. Back-to-back negatives turn into a plus. 3 plus 9 makes a positive 12. You might be asked to multiply. A monomial times a polynomial is using the distributive property. Remember that coefficients multiply, but exponents of the same base add. Negative 3 times 2, negative 6. P to the fourth, p to the fifth, make p to the ninth. Coefficients multiply, exponents add. Negative 3p to the fourth times negative 6p, positive 18p to the fifth power. Remember that a solitary p means p to the first power. They don't usually write it, but it's there. 4 and 1 make 5. Negative 3p to the fourth times an 11r. I hope you notice that it has a different variable here. You can still multiply the coefficients. Negative 3, positive 11, negative 33. P to the fourth and r, since they are different variables, they come down just the way they are. P to the fourth and r, a variable combination. You may be asked to multiply a couple of binomials. Some teachers teach FOIL or double distributive property. 2x times 5x makes 10x squared. A lot of students forget that squared part. He's an x to the first, he's an x to the first. 1 and 1 make 2. 2x times a 7 is a positive 14x. Notice he did not have an x, he did. So when 2x came along to multiply 7, 2 and 7 multiplied to make 14. X came over here, saw no other x's, so just stayed x. Negative 1's turn to distribute through. Negative 1 times 5x, negative 5x. Negative 1 times positive 7, negative 7. The two terms in the middle are like terms. Since I'm kind of running out of room, I'm going to put it over here. I end up with 10x to the second power. 14x minus 5x is a positive 9x, and then the minus 7. You may be asked to multiply a binomial and a trinomial. Take the 3m, multiply all three terms, then take the negative 4, multiply all three terms. you will get 6m to the third power plus 3m to the second power. Remember, if there's not a coefficient as well, that also means 1. An m by itself is like a 1m to the first power. So 3 times 1 is 3. Let me draw a better 3 here. And m1 and m1 make m2. 3m times the positive 8, positive 24m. Negative 4 times 2m squared, negative 8m squared. Negative 4 times 1m, negative 4m. Negative 4 times positive 8, negative 32. I got 6 terms now. There are some like terms here and here. So I end up with, again, I'm going to come over here to write it, 6m to the third, 3m squared minus 8m squared, negative 5m squared. 24m minus 4m is a positive 20m, and then a minus 32. Factoring, this is the key one. It's kind of the reverse of multiplying. You are asking yourself what multiplied to make these. Some of you may notice that I left out factoring with the GCF. It's primarily because I didn't have enough room to get them all on there. So if you need more help with that, make sure you ask me, alright? X squared plus 6x plus 5. As long as there's no leading coefficient, the first two terms of each binomial is going to be an x, because x times x, when you FOIL or distribute, is what makes the x squared. The back numbers multiply to make the back integer here. So we got 1 times 5 as our only option there. Remember that when you're checking for your numbers and your signs, that if your back sign is a plus, like it is here, you're looking for numbers that add to make the middle. 1 and 5 do add to make 6. It also tells you that your signs are going to be the same, either both plus or both minus. Just look to the middle to see what they both are. Since there's a positive sign in the middle, they both get pluses. If you're ever unsure if that's right, feel free to FOIL or distribute. If you end back up with that trinomial, you did it correctly. Next up, x squared plus 8x minus 20. X and x. And now I'm looking for numbers that multiply to make 20. That could have been 1 times 20, 2 times 10, or 4 times 5. How do I know which ones to choose? Again, check your back sign. If the back sign is a minus, you're looking for numbers that subtract to make the number in the middle. For our situation, that would be 2 and 10. They subtract to make 8. If the back sign is a minus, it also tells you that your signs for your answer are going to be different. And the biggest number is going to get whatever's in the middle. So since 10 is bigger than 2, he's going to get whatever's in the middle, and by default, the 2 will get the negative in that situation. Part C, again, my 2 sets of parentheses, x and x. Numbers that multiply to make 50. 1 times 50, 2 times 25, 5 times 10. According to my back sign, I'm looking for numbers that add to make the middle. 5 and 10 add to make 15. It also tells me my signs are the same. They're both going to get what's in the middle. This time what's in the middle is a negative, so they both get a minus sign. Up here they both got a plus sign, because the sign in the middle was plus. Down here they both get a minus sign, because the sign in the middle is a minus. Part D, x and x. Numbers that multiply to make 42. 1 times 42, 2 times 21, 3 times, what is it, 14? Is that right? I believe so. 12, 1, 4. 4, nope, 5, 6 times 7. And since the next number is 7, I know I'm done. According to the back sign, I'm looking for subtracting numbers that make the middle number. Notice I don't see a number in the middle, but if I see a solitary x, that's a 1x. So the number I'm looking to subtract to is a 1. 6 and 7 certainly do that. Back sign is a minus. Tells me I'm going to have different signs in my answer here. One's got to be positive, one's got to be negative. The big number gets what's in the middle. 7's bigger than 6. This time what's in the middle is a negative. So the 6 gets a positive, and there you have it. Hope that helps out. Again, it's important that you really master this to be able to move on throughout algebra. See you tomorrow, guys.